Okay, so we've talked about evaporation, we've talked about vapor pressure. Now we need to talk about boiling. Now boiling is different from evaporation. I think we all have this sort of sense of that, because evaporation happens at any temperature, whereas boiling usually happens at a specific temperature. So for water, water can evaporate at 25 degrees C, but won't boil until you have it up to 100 degrees C. So boiling is specifically, it's a form of evaporation where the change of state is not just happening at the surface, but it's happening all through the liquid. So I want to ask you guys a question, because this is a misconception a lot of people have. I want to ask you, when the water is boiling, you see bubbles. I want to ask you guys, what's in the bubbles? What is the gas that's making the bubbles? Most of the time people tell me it's air. It's not air. Air is out here. Air is outside of the water. There's no air in the water. I mean, there's some dissolved gases. But think about what boiling is. Boiling is turning the water into vapor, or turning water into a gas. So the water, these bubbles, is water vapor. That's what's in the bubbles. It's gaseous H2O. That's what's there. So it's a form of evaporation where it's just happening everywhere. So this happens because the average kinetic energy of the particles has gotten so great that not just the particles at the surface of the water have enough kinetic energy to break free, but water molecules everywhere have sufficient kinetic energy to start breaking free. This causes the bubble formation, the bubbles of water vapor. The boiling point is the temperature at or above which this happens. Now here's the thing. What defines the boiling point is this. It's the temperature at which the vapor pressure of the liquid becomes equal to or greater than the atmosphere. Well, that's not the boiling point. Water will boil if its vapor pressure is greater than the atmospheric pressure. However, the boiling point, that transition point, that is the temperature at which the vapor pressure of the liquid becomes equal to the atmospheric pressure. That's it. So at 100 degrees C, which is the established normal boiling point, right? This is based on the normal boiling point. Do I have that definition? Normal boiling point. Perfect. The normal boiling point is the temperature at which liquid boils under a pressure of 1 atmosphere. So we can conclude that at 100 degrees C, the vapor pressure of water is what? Is 1 atmosphere, or 760 torr, right? That is the temperature at which the vapor pressure of water becomes 1 atmosphere. Okay, so let's talk about boiling point. Boiling point is affected by pressure. So down here at sea level, water boils at 100 degrees C. But if I go to the top of a mountain, how is this going to affect my boiling point? Right? The normal boiling point is still the same, but the practical boiling point is different. It's 100 degrees down here because the atmospheric pressure is 1 atmosphere. But if the if the atmospheric pressure becomes less than 1 atmosphere, right? The atmospheric pressure is less than 1 atmosphere, then the boiling point of water, right? Think about this, if the boiling point has to go up or down, right? So if the atmospheric pressure is less than 1 atmosphere, let's say it's 0.82 atm, that means that my vapor pressure of water only has to get up to 0.82 atm. Now, what two things affect vapor pressure? Because remember, vapor pressure is just a measure of how quickly something's evaporating. Well, the two things that affect vapor pressure are the identity of the substance. So for water, that's just locked in. The other thing is temperature. If I increase the temperature, I increase the vapor pressure. So if my atmospheric pressure is less, then my water is going to boil when it reaches a lower boiling or lower vapor pressure And so the temperature needed to get to that vapor pressure is lower than it would be at a higher pressure. So, long explanation shortened up, at higher pressures the boiling point of liquids is increased, and at lower pressures it's decreased. Because this atmospheric pressure is what you have to match. So if I put water in a vacuum, then I can boil water at room temperature. Water will boil at room temperature. If I bring the pressure around it down enough so that the vapor pressure of water at room temperature is very low. It's like it's about 24 millimeters of mercury. But if I can bring the atmospheric pressure down to that, then water will boil at that temperature, at whatever temperature that is, room temperature 25 degrees C. So I can totally do that. The other thing to keep in mind is how boiling point is going to be affected by attraction between particles. So I'm going to go back to the thing I used during the last lecture, which is water versus acetone. So we established that acetone evaporates faster because it has weaker attraction between the particles, which means that it has a higher vapor pressure at any given temperature than water does. So if I put them both at 25 degrees C, whatever water's vapor pressure is, acetone will have a higher one. So for both of these liquids, in order to boil, they have to, at 1 atmosphere, they have to get their vapor pressure up to 1 atmosphere. So, but acetone has a higher overall vapor pressure at every temperature. So as I'm increasing the temperature from 25 degrees C up, which one is going to boil first? Acetone will boil at a lower temperature. Okay, so I also want to be careful. I want to make sure you guys know something about the way to answer questions on a test. Be very precise. A lot of times people really like to think in this way, if I'm heating them up, which one's going to boil first? There's so many assumptions involved in that, assuming we're keeping them both at exactly the same temperature all the time. First is so weird. Make sure you say acetone will boil at a lower temperature. That's what it really means. It's boiling at a lower temperature because its vapor pressure is higher, and its vapor pressure will reach the necessary 1 atmosphere at a lower temperature than water will. Water has to get up to 100 degrees C. Acetone has a lower boiling point. So boiling point is affected by pressure, of the atmospheric pressure, and the identity of the substance.